Hello, my name is Marcos Chibangu. I'm here to demonstrate the operation of an induction motor and also taking advantage to demonstrate the Faraday's law of induction and some other electromechanical laws as we study in ECE 535 taught by Dr. Wagner at North Carolina State University. Today I'm using this small induction motor which I have already disassembled. This first part is called the stator. It is the fixed part of the motor. It's physically connected to AC power to create a changing magnetic field through this winding. This is a two-winding stator surrounded by a magnetic core made up of iron laminations to prevent eddy current loss. The second part is the stator. It's the rotating part of the motor. It's not physically connected to AC power, as you can see, but it takes advantage of Faraday's law of induction by using the changing magnetic field created by the stator. An EMF is induced in its windings. As you can see, it's a multiple winding rotor. Therefore, the name induction motor because the rotor have its excitation through inductions. It will rotate with a mechanical speed closely related to electrical speed or frequency. Let's move to the experiment. Our first series of experiment will be using a 24 volt AC. We will use this transformer to step down 120 to 24 volt to activate the stator. We've been saying that the magnetic field is created into the stator. Our first demonstration is to show the existence of that field. As the switch is on, you can see that the line of field drive the wire and create some vibration into it. I can do the same thing with a permanent magnet. The permanent magnet already have some magnetism in it. When I flip the switch, the vibration is even more intense. Now we both know that there will be an existing magnetic field into the stator. Let's both find the direction of this field as I put this small thread of wires. When I flip the switch on, you see that they are both lined up in the direction of the field. You see, this is the north and south pole of the field. In our next series of experiments, I'm going to repeat the same thing I did, but this time I remove the 24 volt transformer and connect the stator directly to 120 volt. As you can see, when I flip the switch, the vibration is even more intense. This is to show that the magnetic field is increasing as the voltage increases. I can replace the wire with the permanent magnet. When I flip the switch on, you see the magnet is repulsed because the magnetic field is increased with the increase in voltage, so the repulsive force is even more intense that drive the magnet off. This is just to show you that the magnetic field also is proportional to the voltage, to the AC voltage applied. Thanks for sticking together with me. We both demonstrate the existence of the magnetic field into the stator. That magnetic field will induce voltage into the rotor. This is the Faraday's law of induction. So next thing what we're going to do is reassemble completely the motor. Try to run it and to show the effect of induction into the rotor. This is how the induction motor is done. It's a very simple design, very simple geometry. It's robust. Only use induction. There's no permanent magnet, no brushes. It's very durable. 70% of application industry today use an induction motor. Stick with me a few more seconds. I'm going to show you the motor when it's running at full speed to demonstrate the effect of induction on the rotor. Thank you. Well, this is our motor completely assembled with all the parts put together. So obviously you see the stator, you see the rotor. Trying to run the motor at full speed to see how intense it will be running. So let's plug this to the power, 120 volt, and see how the motor is running. There you go. You can see the motor is running at full speed, and this is the end of our experiment.